dynamic music is something that I find very exciting. So what it is it's when some aspect of a interactive system like a game modifies some aspect of the music playing in that system. And that can be very general. There's lots of things that go into music and there's lots of things that go into games, and any connection between them can form some kind of dynamic music. And so I think this is super interesting because it gives you a space to expand this idea of interactivity that games depend on beyond just visual or gameplay aspects and into the music, and potentially back in the other direction so that the music can impact the game as well. So I think that's super cool, and it's a thing I'm very excited to explore. There are a number of ways people produce dynamic music. One of the most common is called dynamic layering, which is where you have a piece of music that's split into several tracks, not all of which are always playing. So for example, if you have a piece of music with a basic melody and rhythm, and then when something changes, like for instance an enemy appears, you add in a different layer to make the music more exciting or energetic or battle oriented, and then so it changes in response to whatever changed in the game. Another common effect that dynamic music is used for, in fact it's so common that this is often the demo example that people produce when talking about dynamic music, is to make it sound like suddenly things are underwater. And you do that by both changing the layers that are playing, but also adding some filtering. So usually a low pass filter or some changes to the reverb to change the sound of the space. Another effect that's possible is to modify the timbre of the instruments that are playing. If you consider the example where you have some sort of interaction where there's an enemy and that affects the music, but then if you change that interaction by, say, giving everyone fancy hats, which definitely changes the tone of the encounter, you could also have it change the tone of the music, not by adding a new layer or adding a new filter, but by changing how the instruments involved sound. So the way this is implemented in Ortet is with sensors placed in the world that detect the relative position of the player. So I have a couple of types. I have ones that detect how far away the player is, and ones that detect whether the player is within a region. So this is basically the simplest possible way you could implement a system like this, and I tend to make it more complex going forward, but for now, this works pretty well. So the way this is actually specified is, I have a scene file. This is just a RON format file, and among other things, it contains this modulation section, and these are those sensors we were just looking at. So each sensor has a polygon that it applies to, what kind of sensor it is, so like whether or not the player is inside it, or whether it's interested in the distance to the player, normalized to be within some value, and then those get placed on the world. And then in the engine itself, there's a bevy system that retrieves from the ECS store. It retrieves anything that's labeled as the player and its location, the ring buffer that I'm using to communicate with the synthesizer, which is stored in this resource, and then those modulations that we just looked at, which are these guys. And then it goes through and it just checks the conditions. So for every modulation, it checks its type and, looks to see whether or not the condition for that type is met. Is the player inside this thing or not? How far away is the player from the polygon? And then it takes whatever that value is and it pushes a message onto the ring buffer that it wants to communicate to the synthesizer, which is the target, and this is that index into the input ports, which eventually I'll make these some sort of named thing, like a string or maybe an enumeration. so that it's not just these numeric indexes. Currently that's what it is. So it goes to that index in this value to update. And then inside the synthesizer code, there's this stuff, which I'll go into more detail in a future video about how exactly the synthesizer works, but just know that it's a DSP graph where every node takes in either control values or audio from other nodes and outputs its own signal, which could be a control signal or an audio signal. So this is the node that contains the ring buffer that we were sending messages to in the previous code. And it takes no inputs from the synthesizer, because everything it knows about is external, and it outputs some number of output values, which is defined by this generic parameter. And what it does is it goes to its ring buffer, and it just looks for messages every sample. And when it sees a message, it goes to its internal store of what the values for each input port are, updates that value to be whatever the new thing should be, and then every sample it just sends along the current values. So it's relatively straightforward. And then the definition of the current sound that's playing, like whatever the current music is done with this custom language that I have. And again, in a future video, I'll do more detail about this. But this language just defines what the DSP graph that's actually running is by naming nodes and giving each of the named nodes values, which may be expressions that reference other nodes. So in this case, I'm naming a bunch of these sort of input value nodes, which I'll then use later. So for instance, whether or not my ARP sound is playing is tied to the input ports and the first input port. And then I've got others like, is that melody sound playing, or what its gain is, that's tied to the fourth input port. And similar to other things. So then I take those values, and later on in the synthesizer I reference them. So for example, here is where I'm taking the output from a reverb that I've got and plugging it into the final outputs for the synthesizer on 2 channels. And each time I do that, I take this gain parameter, which up here is connected to the 6th input port, and I multiply my output value by that, so that the engine can control the total volume of the synthesizer by adjusting this port on the inputs. So the system is relatively straightforward, but it lets you do interesting stuff. And eventually I want to make this bidirectional, because the synthesizer knows a bunch of stuff about the music, like internal clocks, or like what beat is currently playing, or what the tempo currently is. And it would be interesting for the engine to know that stuff too, so it could do like beat synced motions and things. So eventually there'll be communication in the other direction, which will likely work symmetrically with the current input system, but that code doesn't actually exist yet. And so that's that. Dynamic music is something that I am personally really excited to be playing with this project, and I'd like it to be an integral part of what Ortet is. And I'm really, really looking forward to finding out how to do that as I continue to develop the project. So that's it. I will see you in future videos.